There we go. All right. Welcome to the NetAlly webcast on troubleshooting from the bottom up. My name's Mike Panaki. I'm going to be your presenter today. So we are going to be going in and taking a look at the OSI model, one of my favorite things, and we're going to see how we can use a tool like the EtherScope nXG to help us troubleshoot. Now, I've got some LinkRunner G2s back there. I've got some AirCheck G2s. We would be able to use these to do many of the same things. But we're going to take this all the way out and keep rolling there. Okay, so one thing on these presentations, I do keep an eye out if anyone's having problems, if people can't hear me, things like that. If only one person reports they can't hear me, there's not much I can do about that. If everyone started coming back saying, Mike, you're sharing the wrong screen or I can't see you, then I will stop and fix that. All right, if you've been on one of my webcasts before, you know that I am not really a big PowerPoint person. I like video, I like to get right to it. This one kind of lends itself to just doing a very quick presentation. So we're going to start out with a little presentation here, and then we're going to get into the meat of it. We're going to start clicking on some things and seeing how we actually apply all of this. So let's give this a try. We're going to come in, we're going to share that right there. All right, so in this presentation, we are going to be talking about troubleshooting from the bottom up. So our agenda here, the agenda is a structured approach to network troubleshooting, okay? So that is the key, is a structured approach. We're going to use the OSI model as a way to troubleshoot problems. And the reason we're going to take the structured approach is because of the issues that a lot of people run into trying to get to the root of a problem. So a big part of this is isolating the fault domain. We want to identify exactly where the problem is. And by having these 7 layers to work with, it makes it much easier to do that. We're not just looking at the whole picture, we're breaking it up and we're running specific tests to test each one of those. We're going to identify the problem, we're going to formulate a fix, and we're going to validate the fix. These steps are the steps that I want you to take when you go in to troubleshoot a problem. Okay? The network is slow. This is always how it starts, isn't it? Somebody calls up and they say, the network's slow, this isn't working. And it becomes your job to figure out why. So what I'm going to do is I'm going to show you some approaches that we can take to getting in there and figuring out exactly why that network is slow, resolving it, then retesting it to make sure that it's fixed. Because I do not want you using the S word, and that should. It's really easy to use. That should fix it. That should take care of it. Well, I want to make sure that you're not using that, okay? So, how do we approach the problem? Well, this is some typical approaches people take. They guess about what's causing the problem. I love this one. You get a bunch of people in a room and they say, hey, this is, I'm thinking that this is it, or I'm thinking this is it. Oh, I saw that one time. Well, what we find is that is a horrible approach, because what you're doing is you are basing the problem, or what that problem could be, on what you've seen in the past. And you're not looking at what's actually going on the network. People start making changes without any sort of plan. So you just go in, oh, I think it's this, change it, and now we've changed the environment. So how do we know that we didn't change something that's going to cause more problems? Or you change multiple things at the same time. Well, I'm in here, I've been meaning to make this change. And now you could have fixed the original problem and thrown another problem in there. Without any baseline, we don't know what things to look at, so it's important to create a baseline. We have multiple people making changes at the same time. These are things that we see occurring in typical environments when people are going in there to troubleshoot problems. So here's what we do in taking a structured approach at troubleshooting a problem. And with a structured approach to troubleshooting a problem, what we're going to do is we are going to prepare for the problem before the problem occurs. Okay? Now, this means following a process. If that process doesn't work, we're going to want to adjust that process, and then we will go back, and if that process didn't work, we'll fix it, try it again. We'll keep working through that. We're going to use the OSI model, our Open Systems Interconnection model, as a structure for doing this. And what we're going to find is that when we go in and start taking a look at a tool like the EtherScope or the LinkRunner G2 or even the AirCheck, it's kind of like we flip that OSI model upside down, and we start at the bottom and we start working our way through. And if any of those layers fail, then we need to stop right there and fix it. We can't ignore that, because the upper layers depend on those lower layers working properly. We're only going to change one thing at a time, and then we're going to retest. Did that fix it? No. Then put it back. That was not part of the problem. We're going to base decisions on facts. Don't guess. Don't hypothesize. You can hypothesize in your head all you want, but when you go in and recommend a change, recommend that change based on fact. Validate that change and document it. Document what you did or what it looked like before, what you did to change it, and then what it looks like after you fixed it. Okay? So isolating the fault domain. The first step in resolving network and application problems is to isolate the fault domain. Figure out where the problem is and where the problem is not. By eliminating those parts of the network that are not part of the problem, we can quickly focus on that piece that is. I've seen people spend a lot of time trying to fix something that isn't broken. We need to figure out exactly what's wrong, and this means understanding our applications, understanding how things work. You need to be curious. You need to look at that flow of communication, how things are connected, and this doesn't happen at the time of the problem. You need to understand your network well ahead of when that problem occurs, so then you can go in and fix it when it does occur. Once we've isolated that fault domain, we can drill into the problem. Dun-dun! Here it is. Here is our OSI model. This is what we're going to be talking about today. Let me just turn this back on again. So I start at the bottom. I work my way up. We've got our physical layer, our data link layer, our network layer, our transport layer, session, presentation, application. Now, a lot of what we're going to be focusing on today is the transport layer down, because as a network administrator, firewall person, etc., these layers 1 through 4 are going to be your main concern. But we are going to test application layer protocols such as HTTP, HTTPS, SMTP to make sure that those can get through our network. Now, I'm a big fan of doing a binary search, because if we can see that our transport layer is working properly, then we may not need to go down. We may need to go up. But if the transport layer isn't working properly, then we're going to need to move our way down. I like to start right down there at the bottom, work our way back up. So I can tell you, when I've done classes, I've been teaching this since '97. When I do classes on this, I see people start rolling their eyes. Oh boy, we need to talk about that OSI model again. However, what we find out is that this is the key. Each one of these is a layer of abstraction. The idea is that we can trade out that physical and data link layer for Wi-Fi. Slide Wi-Fi in there. Now the network layer and transport layer, they don't care. They're still able to get their jobs done, and they don't even care about what those lower layers are. We do. And we need to understand how those lower layers work and what can go wrong with those lower layers. The upper layer will not work properly if the lower layer is broken. A lot of years ago, I was looking at moving to Billings, Montana. So went out there, looked at a house. House was cheap, really cheap. So big, beautiful house. Why is it so cheap? Well, we walk in. What we noticed was that the drywall was cracked. Cracked drywall on a multi-story house, never a good sign. So as we worked our way down through the house, we got to the basement. And there was a crack in the foundation that you could put your hand into. And what had happened was they built it below these what's called the rims, but it's cliffs that go around the town. And water ran down there, ran underneath the foundation, undermined it, and the foundation cracked. And that crack propagated all the way up through the whole house. So I always looked at that as a good example of what happens when a lower layer breaks. It affects everything up above it. And that's what we see in this case right here. So what we do is we start at the bottom, work our way up, and we ensure that each one of those. So how do we do that? We need a way to make sure that those lower layers are working properly. Now we can do a throughput test to verify layer 4 is working. We're going to do that. We're going to do some throughput testing here. There's a couple of different ways we can do that throughput test. And we're going to see how that throughput test can be an indicator that things are wrong. We got our physical layer, and we're going to go through these really quick because I want to get to the tester, because that's the fun part. Physical layer, this is going to handle the encoding of our bits. And this is going to be, our Ethernet. This is going to be our 802.11 Wi-Fi. And we're going to go in, we're going to want to take a look at, do we see errors with that? And this is where we can do things like use these testers to do cabling tests. Is the cabling working properly? Do I have shorts? Do I have breaks in the cable? And really, with the EtherScope nXG, if we're running something like N-base T, we will be able to go back and take a look at the signal to noise ratio, okay? So one of the questions that keeps coming up is, am I recording this presentation? Yes, I am. So this presentation is being recorded, and a link to the recorded version will go out in a follow-up email after the presentation is done. So here's a physical layer problem we run into. I use this one quite often. This is an example of where we were doing a trade show in New York back in '09, and we had some problems with some of the cabling. Things like PoE wasn't working right. We ran into this right here, and this is a good example of where somebody used Cat3 duct tape instead of Cat5e duct tape. No, we don't want to see things like that in our network, and we want to be able to detect them if we do. FCS errors, okay? FCS errors are a good indication that we have a physical layer problem. Now we're going to go and we're going to be able to see a little bit of information about our switches in there. So we're going to take a look at that. Just to give you an idea of the impact on FCS errors, things like duplex mismatches and so on. A good connection, this was a 100 meg connection. We got 86.5 megabits per second using iPerf1. Bad connection. We had a duplex mismatch. We only got 1.2 megabits per second. Now this is a case where ping worked fine. Ping is synchronous. So I'm sending a ping, I get a reply. Send a ping, get a reply. Duplex mismatches don't show up if I do a ping. But if I do a throughput test, they do. We've got our data link layer. And this is where we are looking at point-to-point communications. Now, one of the things we're going to look at with the EtherScope nXG in just a few seconds is we're going to look at how we can do a layer 2 path analysis. This is very unique because we can do layer 3. In fact, I just got a email this morning, a comment on a YouTube video I did on TCP traceroute. That's pretty easy. You can do tracer T. I always love that video of the kid talking about tracer T, traceroute. We can trace a path at layer 3. What's much more difficult to do is trace a path at layer 2, because that way, in that case, we have to communicate with the switches. But that is going to tell us what path we're taking at layer 2 and how we're getting there and what our communication speeds are. Things like bad subnet masks, we can see those out there. Okay, our transport layer. In this case, we can come in, we can take a look at our transport layer, what's going on in there. All right, so we're going to look at how we can measure network performance, what's going through our network, etc. So what we're going to do is we are going to come in, and I'm going to switch over here. We're going to switch over to our EtherScope NXG. So let me get rid of that. We're going to bring that up right there. So there's our EtherScope NXG. So what are we talking about there with the EtherScope NXG? And in fact, if you want, on your screen, you can change the size of the video and the screen there to make the video a little bit bigger if you want. But if I switch over here, here is our EtherScope NXG. Now, if you haven't seen this before, this is an Android-based, highly portable little device. I've got it on a 3D printed stand you can download off of Thingiverse. But this has a 10-100, 1000, 2.5, 5, and 10 gig copper port. It's got a gig/10 gig SFP slot. It's got some USB ports. It's got Wi-Fi radio built in there. Here is the thing. This piece of equipment gives us all of the tools that we need to troubleshoot a vast majority of the problems that we run into on our network. And the other cool thing with it is a platform. And the thing about it being a platform is that it's got the hardware in there to do Wi-Fi. It's got the hardware to do up to 10 gig Ethernet. And what we see on our screen right now are some of the applications that are available on there. Just last month, AirMapper was added for doing Wi-Fi surveys. So I can create a heat map. That was something that wasn't in there originally that was added. And this is the really cool thing is we're seeing more and more applications get added in here. But let's go ahead and let's jump into troubleshooting using that OSI model. I'm going to come in here to my auto test. I'm going to go to my native VLAN. I'm going to hit start. So what I've done is I've gone in, I've connected this to an Ethernet switch that I have right here. And it is now running this auto test. And it's going to come back and it's going to show me that connectivity. So if we came in and we said, well, from a physical standpoint, what's going on with this device? We're going to start it down there at layer 1. So right here, I see that that switch is advertising 10-100 gig, and I connected a gig. I can even expand that. It's going to tell me what the advertised duplex and speed is, what the actual duplex and speed is. So this gives me a way that I can tell that I'm connected to the switch. I'm able to connect on, I've got all my pairs working, and I connected at the speed I expected to. Also, if we back up, it tells me on this particular switch, I am receiving let's see. Let me just check. Somebody said it's only showing, it's not updating. Well, it's, oh, hang on. Sorry about that. Something got hit there that paused that. So let me back up. Thanks for letting me know that that happened right there. That's, let me bring this back. There's our home screen. I got all excited about that. I can go back here to my test, and we are going to rerun that test. And so that should be updating again. Sometimes these things happen. Live demos, always a fun thing. All right, so in this case, we'll just go back again so you can see what's updated there. In this case, we've come in, we've connected. It shows us that we could connect at 10, 100, or gig. We connected at full duplex. So it gives us an idea from a physical layer what our speed and our duplex is that we've connected at. Also, right here, I can see that I've connected, I'm getting 47.36 volts So I have a PoE connection. And what I did is I'm using true power in here. So the EtherScope nXG not only will read what the voltage is, but it's going to draw a current level that I have put in there. I've said I want class 3 PoE, which is 13 watts. Now this will go up to 71 watts at the far end, which is what we would expect from a 90-watt power source. So in this case, not only do I know I'm getting the voltage, but I know that I'm getting the current out there at the far end. So that's great. I can check that off my list, right? I connected at the speed and duplex I expected to connect at. So next, where am I connected? So we're going to start moving up the protocol stack. So where am I connected? Well, this tells me that we are connected to interface gig 4 of this switch right here. And it shows me the location, the contact, the switch, how I learned that. I learned it via LLDP. Gives me the IP address of that switch. So at a data link layer, I know what that device is at the other end of that connection. Okay, well, that's great. I've got that information. So now, as I move my way up, I need to know that at layer 3, I got an address. So now we can come in here. It tells me I was offered 11.109. I accepted it. Here's the subnet. I can see who the DHCP server is. So if somebody has a rogue DHCP server out there, I could see that sort of thing going on. Graphs that out. I can see how fast, how long did it take me to get that address? Okay, perfect. So you can see where we've taken that OSI model, turned it upside down. So now we're able to start getting that information. DNS. If I want to be able to resolve names to IP addresses, I need to be able to use something like DNS in this case to be able to do that. And I had a case recently where I had some problems with my cable modem and it stopped forwarding DHCP or DNS frames. So I was able to use this to determine that, yes, we got connected, but no, we were not resolving DNS. So again, I could see I was able to resolve that. Tells me how long it took to look up those addresses. So now I know DNS is working. Now, as we move up here, we're doing some we're testing to make sure that we can establish our TCP connections to things like our mail server, to this server right there. Now, I told you one of the things that we're going to look at is what kind of throughput do we get? So this is all great. I was able to tell I got a good physical connection, my data link is working, my network, I'm getting an address, I'm able to get via the network from end to end out to the internet, and TCP is working. So layer 4, working great. In fact, I can even get up there to layer 7. If I come out here and look at NetAlly, it tells me how long did my DNS take? How long did it take to establish my layer 4 TCP connection? How long at layer 7 did it take to get the first frame of data and then transfer that data so I could get an idea of, in loading that website, what took the longest? Well, data transfer took half that time. So now I've got a good picture of what's going on in there. I told you earlier that one of the things that I'm curious about on here is throughput, because just connecting is not always a good indicator. So what I want to do is I'm going to run a test. At layer 4, we're going to do a throughput test. And we're going to see, can our network support the throughput that we expect? So I'm going to come in here to performance. And we are going to switch services here. Okay, let's go back. We're going to turn this one off. We're going to turn this one on. Now, what this is one of the EtherScopes, or not EtherScopes. This is one of the LinkRunner G2s. that's sitting over my shoulder right there. And what we're going to do is we're going to do a 1 gig throughput test to that device. That's not a gig. That's 39.4 megabits per second. So I'm going to go ahead and stop for a sec. I'm losing 96% of the packets. Well, let me try the other one. Okay, I'm going to try 104. That's back there too, and that's on another switch right next to 106. So I'm going to go ahead and hit start on there. Maybe my network isn't capable of doing gig. No, we're getting 998.7 megabits per second with a packet loss of 0.11%. I'm going to stop. I don't want this to mess up my presentation here. But what we find is we can get to 104 okay, but we can't get to 106. So now what we need to do is take a look at layer 2 and layer 3, see what our path is between those and see if that path is working okay. Because this is part of that OSI model. At our data link and our network layers, what path are we taking and are we successfully getting through that path? So I'm going to come in here to path analysis. And I'm going to trace a path to 106. Okay, so we made it. We made it to 106. So let's scroll up right here. So I come out of the wired port on my EtherScope NXG. I come into unknown switch 7. I go into the studio desk switch. I come out of port 8 at gig into port 8 of this switch. I come out of port 6 into port 8, out of port 7 into the LinkRunner G2 in reflector mode. What is the problem with this path? The problem is right here. We're at 100 megabits per second. So we could say that should all be gig all the way through. But in this case, it's not. Now, I've seen this before. We've seen cases where a pin is broken on the cable. Pin 7 was broken. We can't get our throughput through there. So if I know that that's the problem, I know exactly which port is having an issue. So what I'm going to do is I'm going to come in here real quick. I'm going to go out to that switch. So I've identified the fault domain. I've identified that it looks like we have a problem between port 8 on studio switch 3 and port 8 or port 6 on the 108T. So I'm going to come back here. I'm going to go to that. And yeah, somebody, for some reason, has switched that port to 100 full. So I'm going to switch that port back to auto. We're going to hit apply. That was the uplink port on that switch. So now that's been updated. So now this goes into validating that fix. So let's go ahead. We're going to rerun this. Now, what we're going to do is we're going to rerun it. I'm going to see. So we see that that one's still at 100. So I'm going to come in. Let's just do this real quick. We're going to go into our discovery. We're going to refresh our discovery. Okay, now our counter starts there at 10%. We're going to refresh the discovery, let it go back out, touch all those interfaces, get the link speeds off of there, find out what's going on, and then we're going to rerun that path analysis. So we're going to wait for discovery to get to 100%. Time flies when we're having fun. It is almost 9:30 here on the West Coast. If you have any questions, now's a good time. I'm going to come back here. I'm going to rerun my path analysis. We're going to hit start. So I'm going to check that path to make sure that that is 1 gig all the way through. We rectified that problem. So now what I could do is I could come in and say, hey, we got that problem fixed, right? All right. Let's go back in. And I could take and upload that to Link Live. So now I could upload that to the cloud. Here's what it looked like before. Here's what it looked like after. Now, the last thing we're going to do with that is we're going to come in here and we are going to rerun that performance test. And I'm going to hit start. Nope, wrong tester. We're going to switch over to 106. And we're going to hit start. Let's rerun that. There we go, 998. So one of the questions is, your demo represents a wired throughput test. Can the same approach apply to Wi-Fi devices? Yes. Let me go in and show you. And I'll tell you what, we have this scheduled for half an hour, but I feel like Richard Gere in Officer and Gentleman. I have nothing better to do than sit here. So what I'm going to do is we're going to come in, and if you have a time constraint, hey, I appreciate you joining me and joining in. If not, let's go ahead and take a look. And what I'm going to do is we're going to come in here, and we are going to, instead of our native VLAN, we are going to connect to the office network, okay? So I'm going to come back. And so just like we connected to the wired network, what I'm going to do in this case is I'm going to come back in here and I'm going to connect to my Wi-Fi network. So this is going to go in and give me the same physical layer information from a wireless standpoint as I would get on the wired. So here it's telling us this is this is where we've connected to this wireless AP. So it tells us which AP we've connected to. Okay. And it's going to show us the information about that connection. So from our physical connection there, what do we see? Okay. So I can get an idea of what do my retries look like? What does my signal strength look like? What's my signal to noise ratio look like? I can get an idea of what my channel is. I can see what AP I've connected to. So now what I can do is I can come back in and I can run a throughput test. Now let's do just a slightly different throughput test in here. And one of the tests that we support in here, and there's a question about whether it supports RFC 2544. It does not currently support 2544. Okay. It does support, let me make sure I get this, I haven't had to say it in quite some time, Y1564. Okay. Now with Y1564, we can get many of the same tests. We can get jitter, packet loss, we get our throughput, and we can run to multiple devices. Plus, we can add things like our QoS. I can change my DHCP bits in there. Now, in this case, we're going to do an iPerf test. So I'm going to come in, and I'm going to configure this. And I'm going to say we're going to use our wireless port, our Wi-Fi port. I'll say OK. And we are going to choose our endpoint right here. I'm going to choose my test accessory. That is that little device right there. That's a little iPerf, PoE iPerf, or PoE powered iPerf server. And we're going to come in and we're going to say, we need to get at least 10 megabits per second. Okay. We're going to do TCP. So I'm going to start my test. All right. Hang on. Let me make sure I got the right IP address for that. This is where we're going off script here. Yep, it's 11.116. All right. There we go. All right, so let's hit start. We're going to run that. Haha, better. So now I'm running the throughput test through my wireless network. I'm using the Wi-Fi card, the 4x4 802.11 AC radio that is in this right now. And I'm using that to measure that throughput through my wireless network. So I can come back and I can see what kind of throughput I got connecting to that network. So I can see my throughput up, I can see my throughput down, and I can set a threshold in there. Okay. So one of the questions, does the EtherScope support AX? I would expect that at some point here we will see an AX radio in there. A lot of that has to do with getting it approved and certified in all the different environments. So can it support AX down the road? Absolutely. It's just a matter of, at the time it came out, it has an AC card in there. So that is one, if you talk to your NetAlly reseller, they can give you a better idea of if there's a time frame for that. That's a little outside of what I'm going to be covering in here. Okay? So with that said, these are the ways that we can use this to go in and start getting an idea of how things are connected up. I just want to show you one more, and that is on my path analysis. We did a layer 2 path analysis within our network here. Now, if I come in and I say, you know what, I want to change that path analysis. I want to change the device. And I'm going to say that that device, we're going to change a name. And let's say I have somebody complaining that email isn't working properly. So I say secure.email, srvr.com. Okay, that's my email server. I change my protocol to TCP. And I change my port number to 25. I come back. I say start. Okay. Now we're doing our path analysis, but notice that right here, we're getting all these no replies. It's stopping at my router. Huh. Well, maybe there's something wrong with my router. So what we can do is I can come in and let's say 993 is another port number we use for that, IMAPS S. So I'm going to come back and I'm going to run that again. Let me look at one of the messages that came through here. So Mike Grindell at NetAlly brought up a good point, and that is it does identify why the current version right now does identify 802.11 AX devices. Okay. So we can tell which devices out there are AX. I just want to be clear on that. Okay. So now, let me go back here. When I come in and I try port 993, it gets through just fine. Doesn't have anything to do with the router not passing traffic. It's not passing port 25 traffic. So if I come out and I look at my firewall out here, oh, somebody's put in a rule to drop 25. So we're going to go back. We're going to change our config. I turn that rule off. Let's switch it back to port 25. I'll say OK, because now I have formulated a fix. And before I can tell anyone that it is fixed, I need to go in and validate that fix. So what do we see? Now we get out on port 25. Okay. So away we go. And okay, so let me just come in here, take a look at a few of the questions. Yeah, so one of the questions is, can it scan and identify the devices out there? So let me just show you that real quick. So we'll come back, go back out to our home screen and go to discovery. And this is one, I mean, we could spend a whole nother webcast on, well, we have, but in this case, I can come in here and I can say, you know what? I want to sort by, problems, IP address, IPv6 address. So it'll listen for what IPv6 addresses devices have out there. We can see what we can filter down on devices. I've discovered 136 devices out there on my network. So I could come in and I could say, I want to filter down on Uta's network. Uta works for me. So now it shows me just the devices on her network. And I could say, you know what? I want to see the MAC address, the IP address of each one of those devices. So I could see, hey, there's a grand stream. That's probably her phone. So if I click on that, not only does it tell me there's the MAC address, there's the IP address, it tells me that that's connected to her switch on interface gig 3, and that's doing that through a VPN tunnel. So we can reach out into other networks and discover what's out there on those networks as well. So let's just do this. I'm going to come in here. I'm going to say I want to do a path analysis to her phone. And we're going to change, we'll do a ping. We'll do port 80. I know that those phones have a web interface on them. So now it says that here's how we get to her phone. We come from the switch right here on my desk, through the switch to my primary router, through our VPN tunnel, to her router, to her switch, to her phone. So again, to wrap this up as far as using the OSI model, we have now traced a path at layer 2 and layer 3 through our network. So I don't want you guessing at what's going on out there. I don't want you making, saying, maybe it's this, maybe it's that. Whether it's this tool, other tools out there, please take the time to understand how to troubleshoot each one of those layers. Take a look at that OSI model. Decide, do I have the tools necessary to troubleshoot each one of those layers? And if you don't have the tools necessary to troubleshoot each one of those layers, find a tool that can allow you to do that. And they're not going to be all free and open source, especially when we get into the physical layer and things like that. All right, so that about wraps it up for our presentation today. We will get this edited, recorded, put together, and get that sent out. So I'd like to thank everyone for joining on, and we've got more of these webcasts coming up. In fact, I'll have to look at my schedule. I think we've got one coming up next week. So please join us, and I look forward to seeing you again in another one. Thank you very much.